Hi, my name is Kai Kreuzer. I'm a software architect at Deutsche Telekom, working in the AI Competence Center. And since beginning of this year, I'm one of the project co-leads of Eclipse LMOS, which is a platform that we have built at DT and open sourced it at the Eclipse Foundation. Organizations that deal with software-defined vehicles are typically medium to large enterprises, and they have IT departments, they do software development since a while, and they have existing teams building professional software. And all such companies are currently now wondering what does the new age of AI and generative AI specifically mean to their software development world? Do they have to invest in new teams, new skills, and how do they deal with that? And that's where Eclipse LMOS comes into play, because we are saying that existing teams should be actually enabled to embrace generative AI, to enhance the applications that they are already building, the tools that they have, the skills that they have, to use all of that and bring it to the new software development paradigms that are now following with generative AI. And so Eclipse LMOS mainly targets the cloud native application development, like microservices, architectures, scalable, and to have the very same concepts for AI agents, which are small modules that can be developed independently by different teams and assembled together in our big applications together. Well, LMOS as a platform has many cool features, and maybe let me point out two of my favorite ones. The first one is a Kotlin-based DSL, a domain-specific language, which enables developers to very easily create AI agents by really just describing them through some natural language. And being a domain-specific language based on Kotlin means that this very simple starting point can be evolved into a very complex, multi-tenant capable, production-ready deployment artifact, because you have all the breadth and features of the Java ecosystem available at your fingertips, and you can also make use of all the Kotlin language features. So it's very easy to go from a small POC, an initial demo, into a scalable deployment for your system. The second feature I would like to highlight is everything around the life cycle of agents. So similar to your microservices in classical applications, the agents become a first-class citizen within a Kubernetes cluster. So you can deploy them independently, you can version them independently, and by leveraging frameworks like Istio, we also provide encryption within the cluster automatically of the traffic, and also enable developers to do, for example, canary deployments, so shifting only 5% of the traffic to a new version of your agent, to do early testings and such things. Yeah, sure. The LMOS protocol is actually one other artifact that materialized out of the implementation of the LMOS platform. And as I said, the agents have their independent life cycle, and by having that independence, they need to have a mechanism to discover each other, to negotiate how to communicate with each other. And this is exactly what the LMOS protocol provides on the platform. And the cool thing about this protocol is that it's not constrained to be used only inside Kubernetes clusters, but you can apply it in any kind of network up to the scale of the internet itself. And we're looking there into our having multi-agent collaboration out on the internet on any kind of network. And the whole idea and vision behind that is to really enable developers to build vendor neutral systems. We don't believe that AI agents should only live in platforms of a few big companies out there, but that sovereignty is really a big deal, not just for individual developers, not just for companies, even for whole countries or economies like the European Union. And the whole idea there is to enable people to decide where to deploy things, how to build it, and have all the communication between the agents are independent and on their own control. Well, to get started, best visit the project website, which is eclipse.dev/LMOS. And besides reading into some of the core concepts, best way then is clearly to get your hands dirty as quickly as possible. There are actually two paths that you can go for. The one is to look into agent development with this Kotlin DSL that we call Arc, where you can do some easy prototyping and see how easy agent development is with Eclipse LMOS. The other path is to try out the LMOS demo project, which sets up a small Minikube Kubernetes cluster on your local machine, deploys some example agents, and you can see the dynamics of having a multi-agent system running locally on your PC.